Okay, in this screencast, we're going to talk about different characteristics of graphs. And so you have a lot of vocabulary that you need to read. So if you did not read all of the vocabulary terms, you're going to need to do that. So you need to pause and read through those. So a discrete graph is a bunch of isolated points, and they kind of don't have a relationship between them. Continuous graph, there's no breaks in the graph, so all your lines are going to be connected. And a linear graph means right in the word you see line, it means it's going to connect a straight line. Has to be straight, and that's what it means for collinear. Nonlinear means it's not going to create a line. So it's just going to kind of maybe make a curve, maybe no pattern, something like that. And by now, increasing, you should know, is you're reading your graph left to right and the line is going up. And if you read your graph left to right and it's going down, would be decreasing. So once you understand the vocabulary, now we can go and figure out if these are functions, what types of graphs we have, so on and so forth. So when I look at this first graph here, I notice that my points are connected. So that would be continuous. And it's not a straight line, it's got this curve. So it'd be nonlinear. And then when I read this left to right, it's actually increasing and decreasing. And if you kind of remember from a previous screencast, you could do your vertical line test, and this would be a function. Each input's going to have exactly one output. So let's move to the graph next to it. So my first kind of set of terms, discrete or continuous. This is discrete. Nothing's connected. Random points. There's breaks between your points. And then I don't see a straight line, so this is also nonlinear. Has no pattern, so it's really hard to form a straight line. And this is neither increasing or decreasing because I don't have a pattern. How can I decide if this is increasing or decreasing? I just can't. And so when I kind of go through, this would be a function based off of my vertical line test. And eventually, we would find that function rule that's fitting these ordered pairs. Let's go to the next two. This would be continuous because my points don't have a break. Continuous. I have a nonlinear graph again. And it's not really increasing or decreasing again, so either increasing or decreasing. It's just one big circle. Can't really read it left to right and tell, are we increasing here, are we decreasing, so on and so forth. So it's either increasing or decreasing. Now next to it, we have month savings and some points. This would be discrete. This actually would be linear, so it doesn't necessarily have to connect, but if I imagined connecting them, it would form a straight line. So I would have a linear set of data here. And then if I Just notice I spelled decreasing up there. Way to go. Okay, back to this problem. Decreasing or increasing. If I read it left to right, I can see the points are going up. So this would be increasing. And I also made another mistake. I never said this graph to the left is a function of that. This one would be not a function because it's hitting multiple points on my lines. All right, so let's get back on the right page. This one is a function. Passes my vertical line test. All right. Last two. All right, so I have pounds, cost. I would have a continuous. That's oh my God, my spelling is just off. Let's try this again. Continuous. My points are all connected. And just proved it's linear. It's forming a straight line when I trace over that. And this would be increasing. Do my vertical line test. And notice that this would be a function. Last one is also continuous, also linear, but when I read it left to right, I see that it's decreasing. And let's do my vertical line test. It looks good, so we have a function. Now I want to go back to two of the problems because they have a little bit more meaning to them and kind of connecting why it's discrete and why this one down here is continuous. So up here, this is discrete data. It's never going to connect because I would never compare in between these points. So discrete data normally is data that you're comparing whole numbers. So my amount of months, I wouldn't be like, oh, well, in 1.5 months, I would have $60. So I would never connect, and I would make this discrete if I was making this my own set of data. Versus something like this, where, okay, sometimes when you go to the grocery store, you might have, a pound of apples. You might have in between a pound and 2 pounds. So this needs to be connected because I could have fractional parts. It's not always 1 pound, 2 pounds. I could have 1.25 pounds. That's weighed at the store to get me my cost. So that's another thing that you need to start thinking about moving forward is, well, why are they connected? Why are they not connected? Especially when they give you some labels, you should be able to determine that. So your definitions are up at the top. You need to know what discrete, continuous, linear, nonlinear, increasing, decreasing. Maybe it's neither, maybe it's both. You need to know all that vocabulary to describe a graph of functions or things that are not a function.